Hi, everyone. Welcome to our community conversation for Siemens Technomatics Virtual User Group. I will be your host today, Kelly Gallagher, on the Siemens Digital Manufacturing Product Marketing team. And today we will explore how to create a lift base on a conveyor in plant simulation. Our speaker is Stefan Bangsau, who has deep expertise in plant simulation, completing hundreds of projects and training sessions. As a leading contributor for the Siemens community, we are thrilled to have Stefan's contribution and user insights. For today's session, Stefan will show you how to set up the play translation method, adjusting the appearance of the lift, and creating a generic program. Please note, as Stefan presents live, we will monitor the chat for any questions and address them at the end. Then after the demonstration, there will be a live question and answer, so you have the option to raise your hand and we can take you off mute, or you can ask your question and feel free to put it in the chat otherwise. Now I will pass the screen to Stefan. Thank you.
Hello, I will take the screen. Hello, everyone. Today's topic is a 3D topic. I will start with a very simple use case. We have, for instance, one source, and we have a conveyor. Then we have another conveyor, very short, only 0.5 meter. And following to that, we have two conveyors in different heights. This conveyor should have a height of 3 meters or 2 meters. And if this we can set with the 3D properties. And in the tab appearance, you can set a different base height, 2 meters. And I copy this. And this I want to rename this to conveyor 3. And this conveyor should have a base height of 3 meters. And finally, we need a train to destroy the parts. And to make it more visible here, I want to let the source produce two different kinds of parts. And so first I duplicate the part from the class library 2 times. I make this, okay. So I have part 1, part 2, and part 2 should have another color. So I need to change 3D properties, appearance. I activate the material, and the second one is green. And the part 1 is gray. And now I need one table. I rename it to mix. To define the production sequence of the source. And I create part 1 and part 2. One by one. Okay, so we have one basic scenario. We have one conveyor, then one short part of conveyor, and this should distribute these two kind of parts to two levels of conveyors. And to make this here running, we have several ways here in plant simulation. One way would be to take a lift, and we have a lift here in the Cranes and More library in plant simulation. And you could use this lift to do this. And you can see in version 2404, the lift is also based on the conveyor here with a lot of adjustments, but I don't want to use this lift. I want to create my own lift based on this short conveyor element here. And first I need to change something here. The lift, this conveyor element has legs, and I need to hide these legs here, and so I need to go to the 3D properties, and in appearance you can set up the appearance of this lift conveyor element, and here you can switch off the legs, and so we have only the conveyor belt element here without legs, and so I can lift this without moving the legs up and down. Next, I want to have different destinations for the parts that the lift needs to transport. Part 1 should go to conveyor 2, and part 2 should go to conveyor 3. And the easiest way to do this is to define exit control here in this conveyor and set different destinations to the parts. And so the first small control I need is an exit control here in this conveyor. And this is quite easy. If the name of the part is part 1, then the destination is conveyor 2. It moves this part to my lift here. So it's only to differ between these two part types. And now I need to develop one small method to move this conveyor element in that direction. And we have several ways to do this in plant simulation. One way would be to create one animatable object here on this conveyor and then move this element up and down. A second way is to move the complete element up and down. And for this we have a method, late translation. And we need several steps here in this method, and I will make this method here as an entrance control of this conveyor here. Lift entrance control, and it should be triggered with the rear when the part is completed on this lift element. Then this method should be called. And to avoid that other parts are enter this lift, I want to lock the entrance here, and I also want to lock the exit so that the part is not automatically be transferred via the connector here. I also could delay the connectors, and so we need to do several steps here. The first step is close then I need to lift. Then I want to move the part to its destination, and then I need to lower the lift. And these are the steps we need to do here in this control. And first, close entrance and exit. This is easy. We can use entrance locked and exit locked for this. With question mark, I get access to this lift here, because the control that is triggered, it's inside here, this element. To lift, I need the height I want to lift, and we cannot use here the position of this element here, because if I open this in 3D, then you can see it is not on the set 0 position. But if I go here into this element or in the 3D properties, then the position set is 0. So this position of this belt is not the position of the element, and so we need to read another attribute for this, and you'll find this in appearance, is the base height. And if you go here on the direct help and click on base height, then you'll find the SymTalk element, and the SymTalk code is underline 3D base height. Base height. And this is our starting point, and we need to lift to the base height of the next element. And so we can calculate the total amount of height we need to lift the lift. So we need a very simple calculation here. I want to have a variable, and the height we need to lift is at point destination, point underline 3D. So we can access all 3D methods and attributes of the element. And we need the attribute base height. And the difference between the base height of the destination and the base height of the lift, this is the height we need to lift. So I need to calculate this from both base heights. If you make this for a real application, then you will see some start delay between the movements. The lift will not start immediately. You have some communication with your PLC control, and so I have a start delay, maybe 1 second, and then we need to lift our lift, and the method is plate translation. And we have 3 parameters. The first parameter is the start position, X, Y, Z. The second parameter is the target position, also X, Y, Z. And then as a third parameter, we need to hand over the speed of the lift. And we start with 0, 0, 0. And we want to lift, we want to move the lift only in Z direction. And so the offset X and Y is 0. And our variable for height here as Z parameter. And we take, for instance, 0.5 meter per second as a speed. And this method, plate translation, it returns the time it needs to move from this position to this position here. And so we can just place a wait before this to wait until this movement is completely finished. Then we are on the top position and we let the part go. So, and therefore we need to unlock the exit. And move the part to its destination. So we don't need connectors here. Then we need to wait until the MU has left the lift completely. maybe you can take another start delay for the next step. The same maybe you need for before and move. Oh, no, okay. And then we need to go down. And this is the same method, play translation, but the start point is now we start at the height of the second conveyor and go back to 0. And then we can open the entrance for the next part. And these are the basic steps. And it's not interesting how many lifts or how many conveyor you have here and what's the height of the lifts. We calculate the heights dynamically, and so we can check this out. And so this is a quite simple and easy to use a way to create any movements of conveyors, track elements. You can also use to in the same way. And you can move in each direction with the method play translation. And so it's very flexible, and you can create a lot of different animations with this method. So this was a short, quick webinar for today. There's another one here. It's plate rotation, and play rotation you can use to let elements rotate directly. And if you need some very special turning plate, for instance, or turning device, then you can use this play rotation to animate this, for instance, a conveyor to create rotations. And of course, another way would be to stuff the conveyor with animatable objects, and then you can create joints and poses for the element, also for conveyors. You only need to be careful with the animation. The conveyor needs to have animation. Okay, don't see it here. Of type line. This is very important. I don't know, otherwise it doesn't work. But you can create animation structures also on conveyors. Okay. questions? Oh, one moment. Wait. Okay, I have it. Any questions? Okay.
Okay, Stuart, you should be able to unmute if you have a question.
Yeah, thanks. Hi, everyone. Thanks for that, Stefan. Yeah, just kind of comment really, because I guess that's nice and elegant way of doing it, but I mean you're kind of locking the solution to a 3D representation, I guess. So I guess if you wanted to do it in a pure 2D model, you might have to go the route of kind of modeling the lift explicitly at the process flow level, if that makes sense. So modeling it as an actual dummy station, for example, that represents the lift delay and the returning to and from the top. Does that make sense? I mean, or is there a more elegant way of doing it in a pure 2D model?
If you need the time to consume this element, but in a pure 2D model, I would just take a single station to consume the time it needs to lift it to another level. It depends how you model the levels here. You can also model levels in 3D like in 2D, and it's I don't know, it's easier, but you can also use this to run into another level here in 3D. In 2D, you will need interfaces, and with the interface you come in the other level if you want to have several levels. But normally in 2D, I would only consume the time it needs here.
Okay, yeah, that makes sense. Thanks. Yeah, I mean, I guess it partly depends how accurately you want to model the dynamics of the lift, with having to go up and then come back down. And but as you say, yes, you could just kind of hard code it in a set of times, couldn't you? Yeah. Okay. Thank you. That makes sense.
Yeah. But if you have several levels, then okay, it's the same. Then you have a station here and a connector, and then the connector goes to the other frame. In 3D, you can maybe I can show this. Glass box frame. Okay, delete this. Yes. Then I make. Okay, it's not so easy because we need to wrong direction. Okay. Oh. This is now a conveyor. Meters in a different frame, and I can take the same approach to move in another frame. But then I need to to take into account also the height of the frame, the position of the frame here. And so I need to change my method a little bit at destination plus. Oh, this was right. But you can see it's still it's already in another frame here. And my biggest height. Oh, it's not here. This is not right. And this approach you can also use to connect different levels in your 3D simulation, and you don't need any interfaces for this. And in 2D you have only the time it takes, and then let it go with interfaces to another frame. And this is much better in 2D in 3D.
Great. And Stefan, before we conclude, I'll give closing remarks. So I just wanted to let everyone know that this demonstration will be published to the plant simulation community early next week so that you can access it on demand. And then also wanted to share that if you would like to participate more in the virtual user groups, you can go to the Siemens Community Plant Simulation Virtual User Group, and you can select to follow these topics and select every post. This will help inform you of the upcoming virtual user group invitations, and then also notify you of when previous on-demand recordings have been published. So as Stefan mentioned, if you have other suggestions for other upcoming sessions, please drop those in the chat. Otherwise, we have 2 meetings, one on Wednesday, May 7th, and then on database access using Python, and the other on Wednesday, May 21st for energy simulation of transporters. So please feel free to follow along and you'll get notifications of when these events are taking place. Lastly, before we conclude, we wanted to share information about Siemens' upcoming user event, Realize Live. We do host the event in the Americas, Europe, and Asia. So Realize Live in Americas will be taking place in Detroit, Michigan in the first week of June. It's a 4-day digital transformation event for all Siemens software users where we connect users and industry experts and partners to share insights and explore the latest trends, technologies, and best practices. So Stefan will be there presenting about Python integration in Detroit. If you happen to be there, make sure you stop by for his session. And also here is information on Realize Live in Amsterdam, Netherlands. We will have our Plant Simulation User Group Conference on July 2nd. The user conference brings together industry experts, plant simulation users, and Siemens specialists to share knowledge, insights, and innovations about discrete event simulation. So make sure to register if you haven't already, if you're located there, and make sure to join in for a full day of presentations, technical sessions, and discussions. We'll cover topics from optimization strategies, Python integration, and AI-driven simulation approaches. So we invite you to join.
We have now some things here in the chat. Fluid simulation we can do, but what do you need special in fluid simulations? Can you be a little bit more detailed, please? AN? For manual operations where operations are involved, the operation efficiency is different during work shift, after lunchtime, or operator moving a heavy part or using a hoist instead of lifted by hand, or if the operator is new hire versus old hired. Yes, this we can do. I have one example for yes, you need to change the efficiency dynamically, but it only works for processing. For transport operations, you only can change the speed the worker is going, and you can adjust the loading and unloading times dynamically, but we can do this, yes. How to start to become an expert in plan simulation? Yeah, it's a long learning process. You should start with the material you have here in plan simulation. I take the screen again. And for the first steps, I recommend to use the step-by-step help. You find it here in help, contents. And then there is a step-by-step help here. And here you can find printed, it's more than 2,000 pages material for really start with plan simulation. And you should go through all this material before you start to try more complex stuff. And of course, you have a example collection here in plan simulation. And you can also try, if you are done with the step-by-step help, you can read my book, for instance. And so, but here it's really a lot of what's new, interviews, how to start, and you can find here a lot of steps you can do. Simulation of a waterboarding plant. Okay, we have only half an hour, and so we can do this. Yeah, we can do some steps of this. For instance, filling the bottles and running the bottles over the conveyor. And yes, we do some webinars with fluids. Yes. Which is the best AI large language model that generates the most accurate SimTalk scripts? ChatGPT gets it wrong a lot of time. ChatGPT now makes it together with Python, and so it's not good. You could try the Chinese DeepSeek, yes. Oh. And the European are not so bad if you try LeChat, but DeepSeek is special. They have a special training made for DeepSeek and plan simulation, and so it creates quite good code, but maybe 90% accurate, and so you need to correct 10%. Can I change 3D visual representation of a mu? Of course you can. Okay, I need to close this here. First, you need to duplicate one and then open this in a new 3D window. Then you have here the 3D. And the easiest way is to right mouse click here into the background and then exchange graphics. And this will lead you to one folder in your Blend Simulation installation. It's 3D S3D graphics, and there you have several containers. For instance, here is a box, and then you can open it, and then it's a box. It's not anymore this appearance of the MU, and you can also import JT files, step files, iGest, what you have. How to connect BlendSim to MySQL Server? Several ways. One way would be to use ODBC, the ODBC interface, but you need to use a 64-bit interface for MySQL. So you need to have a MySQL driver. You install the driver on your computer and create a data source in your operation system, and then you can use ODBC to connect, or you can directly connect to MySQL Server with Python. And this I show in the next. How to position multiple parts next to each other that are not in sequence, it's not possible. Then you need to create several conveyor lanes, and then you can transport side by side. But in Blend Simulation, you can only transport sequentially on a conveyor. Okay, then thank you. We will continue in 2 weeks. And have a nice day, nice evening, nice afternoon.
Great. Thank you, Stefan. Thank you, everyone, for joining.